Thank you so much, Tracy. That was fantastic information on all of the things that the government has been doing to increase international trade. I am delighted now to introduce Aleksander Gorkowienko, who is a qualified IT professional with over 20 years of practice in business. And during the past 10 years, his primary focus has been on cybersecurity, cyber resilience, and ethical hacking. He's a practitioner delivering penetration testing services and cybersecurity training for many years, and is now the senior consultant of Spirent Security Labs team. Today, he's going to be talking about SCADA systems and the security and what we can learn from those mistakes. So without further ado, I'd like to introduce Aleksander. Who is on mute?
That's usual. That's a sign of 21st century and well, the situation we are in. All right. Good morning, everyone, again. And yeah, so I hope it's not too early to talk about security of industrial systems. So we have our first coffee, and we can dive into quite interesting things. Share my screen. Okay. So before we go further, let's talk a bit about what SCADA, what industrial control systems are. Where are they? And they actually, surprisingly, they are everywhere. We don't see them, but they control all industrial processes. They control manufacturing processes, power generation, all critical national infrastructure, all oil and gas pipelines, water treatment, distribution. They're all over us. It's all transportation, all vehicles, tankers, airplanes. So surprising as it is, it actually controls our life, as we know. Those systems, it's all IT, but not entirely IT. Those systems are quite often proprietary. They have very long service and service lifespan. Sometimes it could be even beyond 20 years. It's not surprising because if you do, I don't know, factory acceptance tests for, I don't know, nuclear power plant, they could take like 3 years or more. So this clearly means that once the device is there, it stays there. Those devices are not easily upgradable. Sometimes they're not upgradable at all. They quite often use specialized communication and many legacy and old protocols that were designed, well, 10 years or more than 10 years ago, before someone thought that our modern shop floor, they could be connected and controlled over the internet. So no one thought about security because, well, the client was always detached from the rest of the world. Whatever happens inside, what happens inside. But these days, those legacy protocols, they're wrapped inside those TCP and UDP we all know. And yeah, important thing is that this all was never designed initially with security in mind. So from hackers' point of view, it's very interesting. It's very, very hackable. Let's take a look at the typical ICS infrastructure. So we have on one side, we have corporate network where we have all management of modern organizations, and we also have all known threats like viruses, Trojan horses, all type of malware, ransomware, etc. And on the other side, we have control network where we have all those PLCs, so programming logic controllers, we have field devices, we have sensors, we have actuators, everything that actually makes the manufacturer working, right? So in an ideal world, we can say, yeah, if you want to have security in both sides, we have to detach them completely. But in the reality, it's not possible because from one side, yeah, it would be good to detach them, but at the same time, whoever is working on the corporate side, they want to have a visibility and control what is happening with our manufacturing processes, how everything works. Therefore, it's impossible to disconnect them completely. So therefore, we have all those modern solutions like data diodes or fancy industrial gateways or firewalls. So they might help, but not entirely. And we will learn why. So SCADA security. It's a rhetorical question. Is SCADA secure or not? Probably you should answer this yourself. Well, I can share with you my point of view. I think ICS and SCADA systems are, first of all, managed by engineers and not not IT personnel, especially not qualified IT personnel. And with all respect, because I know many engineers myself, and they're brilliant, they're very clever people. They managed to build insanely complex and really great systems. But quite often, these people, they don't have really good understanding of basic security principles even. Therefore, again, it's asking for trouble. We have a situation where many legacy systems, again, we sold maybe 10 or even 20 years ago, working side by side with the newest solutions. And again, in this circumstance, it's very difficult to enforce unified security approach. Coming back again to my initial point, those systems were not designed for testing. It's like literally one of my friends say, just, it works, don't touch. So that's the same thing with all those systems. They are not even able sometimes to withstand normal Nmap scan. So they're just going down. And probably the last thing we want to run a penetration test against the live environment and put the manufacturer down. So yeah, I managed that critical systems have proprietary protocols. Quite often people who are designing them, they're thinking that, yeah, we can hide something. We can hide this folder or this kind of technical backdoor functionality. And this is a typical example of something called security by obscurity. But in reality, it means no security. And as a practitioner in this area, I can tell you that, hackers and also pen testers, they have tons of different tools that give us a chance to discover whatever is hidden. So it's really not the right approach. And also famous myth of security by air gapping. Yes, we want it, it's very important, but it's very difficult because, again, the technology goes forward very quickly, and also technology of exploitation goes forward very quickly. So we have, sniffing in the air. We have, intercepting Van Eck fields or sniffing, radiation or even thermal heat. And there are multiple ways how you can not only sniff but transfer data from air-gapped system. So unfortunately, it's never be ideal. And one more very important point I want to make here. So problems in IT world are significantly different from problems in OT world. Because in IT world, let's say we have hacked web server, well, the worst thing could happen. You have to restore the data from the backup, and that's the only thing should happen, right? No major harm is done. Well, we can obviously discuss whether it's major or not. But in case of a problem with OT security, it's, hacking, let's imagine the power plant or refinery manufacturing, consequences could be very, very serious, very severe, physical. And it could not only affecting, damaging physical infrastructure, and it also affect the safety and security of people working there. And well, to be honest, if the oil refinery goes down, it will be impossible to bring it up from the backup, right? It means it will be down, or oil rig, right? It will be down for months probably. So obviously the loss of money will be quite significant. But yeah, very important is that people's life is also at stake. So for hackers, it's very, very important, and it's its ultimate goal to find the best way how to break the air gap. And here I probably should mention quite interesting, very old concept called Occam's razor. It's quite old philosophical concept saying that, if there is a goal you have, right, not necessarily you should pick the most complex way to reach it. So the hackers really, they know this by heart, because whatever they do, they use the simplest, easiest ways first of all, and then they go to complexity. So all those malicious USB pen drives, yeah, exactly as old Stuxnet was distributed, all still perfectly works. Hacking through, technician and the field engineers' laptops or field devices, it's the same story, right? The device was, built and configured 10 years ago, and it has the same old, PDF reader, right? And it's obvious it's asking for trouble, right? It's very, very easy and nice to exploit. Another example is hacking through supply chain, where, well, if you think about hacking the, car manufacturing facility or nuclear power plant, probably it would be, we think it probably should be complicated, right? But because we can't get there, because there are multiple layers of defense. But if we can hack through supply chain, if we hack the PLC or device that actually will be used inside of this manufacturing, then it will be quite easy. So, and again, coming back to the concept of that those devices, once they're there, they stay there for really, really long time. Once you manage to do this, you have pretty much perfect backdoor staying there for tens of years, really. And I think the very good example of that we had recently, and obviously it's famous SolarWinds hack. So Spirent Communication, all type of SDR, and again, many years ago, it was very difficult. Those devices were very expensive, but now it's not so difficult at all. You know, you can buy a small USB dongle that normally works as a USB TV tuner, and it can be reconfigured to become a full-featured SDR. So you can sniff wireless communication and do it the way only military were able to do it not so long ago. So there are multiple ways how we can break the air gap. Another interesting thing is that there is a new generation of ICS remote clients. And, well, initially, all control was local, right? There was like a PC connecting to all these robotic systems or sensors and actuators, and from there you could control the manufacturing process. But now we have a new generation of those clients, and these are from the web. You can basically control the technological process through thousands of miles, which is great because you can do it from your mobile device, you can do it from your computer, but it also means that you're introducing good or well-known vulnerabilities known for web applications like SQL injection, cross-site scripting, direct object references, LFIs, RFIs, and this means that again, it's very nice environment for hackers because we are introducing known vulnerabilities to the environment where in ideal world we should not have a single one at all. So what hackers use, obviously they use lots of typical networking tools and techniques used in network and in infrastructure assessment or hacking, tools for wireless assessment, for reverse engineering. If you want to be proficient in this, you definitely need to know programming, at least Python or any programming language like C, C++, because you need to do lots of scripting, intercepting packets, changing them on the fly, playing with hardware, have ability to connect and use, different industrial protocols like Modbus to be able to connect to hardware directly. And, well, last but not least, enough time and curiosity. But I think this is what hackers always have in abundance. So I want to share with you an interesting case study. It's the assessment of something called FPSO. So FPSO is a floating production storage and offloading vessel, a very long name. It's used as a huge, huge ship. It's used for offshore oil and gas industry. And it's basically like floating manufacture. It's located near the offshore drilling platform, and this is where it connects to the drilling platforms through different pipes, and it takes the crude oil and everything basically that is taken by drilling platform, and also provides in return different chemicals that are needed for the whole process. It could also partially or fully process the oil just on the ship. So it's quite interesting thing. And we've done assessment of all these IT system that is managing all this machinery on FPSO. And the report was quite large, but I want to share with you only three probably most interesting things. Obviously, one of this is breaking the air gap and accessing the AirGap HMI server, a bit about PLCs and using man-in-the-middle attack, and also about hacking NTP server. So let's start from hacking AirGap. So AirGap server, so it's a machine that controls, let's say, the whole technological process on FPSO. So it connects to dozens or if not hundreds of different PLCs, and those in turn they connect to different actuators and sensors and etc. So all this stuff is located in a massive cabinet with the walls like inch thick. So it's impossible to get there. You have to get through several levels of security. So you can't have direct access to all that machine. The only way to connect and access this HMI server is through fiber optic KVM, and even physically they are located, as you can see on the picture, in completely different places on the ship. So if you could go to FPSO control room and you see only the screen, keyboard, mouse, and that's it, and you have access to this HMI server. So the idea is how we can get there, how we can manipulate it, and maybe, I don't know, insert or introduce some sort of potential malware or basically hack this HMI server and also take some sensitive data from it. So first analysis quickly showed that whatever we have there is Windows 7, which is totally great, and is unpatched, and there is no AV, which is totally, it's even better. So HMI initially supposed to be working as a kiosk with no access to the operating system, but again, for someone who is working in this, it's not so difficult to have access to the console and basically do whatever you like. So first thing we try to find out is how we can, well, transfer something there, and this is quite interesting idea. So we thought that we can hack the server using literally a notepad.exe, and one more tool that is like a default part of any Windows installation called certutil.exe. This certutil is a tiny utility which is used normally for nothing completely harmful. It's just used for converting security certificates. But from, again, our point of view, it was priceless because it's done exactly what we wanted. It could convert any binary like executable to a base64 encoded text file, and also vice versa, to convert base64 encoded text file to a normal binary. So we use another tool called Bash Bunny, and Bash Bunny is, I can call it like, you know, it's a multifunctional device, but we use it almost like a keyboard on steroids. So it's used to replay keystrokes. But again, when we tried to use it initially, it was not so easy because apparently the original keyboard connected to KVM was whitelisted. So we had to connect it to our PC, take those specific hardware IDs of the keyboard, was Dell keyboard, and reconfigure Bash Bunny to mimic exactly the specific keyboard that was connected to KVM. So here is the method. So we take the binary file we want to transfer. Let's say it's our malware. We use the certutil.exe on our machine, on the attacker's computer, and we convert it to something which is normal base64 encoded text file. It doesn't have anything wrong with it. It's just text file, txt. Then we use another script to convert this textual file to the set of instructions for Bash Bunny. And then we open the notepad.exe on the remotely on the FPSO computer, and then we literally inserted the Bash Bunny, and it typed the whole content of base64 encoded file into empty notepad on the server side. Then we used certutil on the server side and converted that textual file to a binary. So we recreated our binary file on the server side, which was totally great because by this method, it was slow. I mean, it obviously took a bit of time, but we could transfer pretty much any binary to the server, which was initially technically impossible. Another question, how you can take the data from HMI server, because you can't insert any USB stick and just copy your files. And there were lots of interesting things. There were lots of configuration files, and in those configurations files were, I don't know, plain text credentials, different IP addresses, and lots of things that you could potentially analyze and explore. So we thought it would be interesting to take it. Also binaries like executables of all these control systems. And I should probably mention that those binaries were we found very quickly they're made in C#, and well, everyone knows that C# and .NET has very nice feature. You can reverse it perfectly to human readable code. So it was we were even more motivated to take those binaries back. So we thought that we can do a very tricky way. So we transferred by the method I described earlier. We transferred the our binary, our conversion tool, to the server, and then you could just take any file and drag and drop it to that little utility, and it produces the QR code. And this QR code on the screen could be read by anything, any tool, any mobile phone. And you can, even large or complex files, you can convert by page. You can, again, scan and recreate and take all the content from the server back to our site. So yeah, that's how we take the data from there. Now let's talk a bit about man in the middle. So a man in the middle, I think, again, it's nothing new really, and it's really well known to hackers, and we just want to show here how we use this to intercept the data communication between the HMI and PLCs. So let's imagine that we can connect to the router and we are part of the switched network. But obviously, in this case, we don't see any traffic between HMI and PLC because the router does not allow us to. So because we have different, obviously, each device has their own network card and different MAC address. So router decides that traffic from HMI goes only to PLC and back. It doesn't go to attacker. So what we can do, we can use typical ARP spoofing. So we can broadcast ARP message saying, okay, guys, from now on, this MAC address, which was initially with HMI, is associated with my IP address. And also the MAC address associated with PLC is also now with my IP address. And you think it's a bit weird, but for both devices, surprisingly, it's absolutely okay. They say, yeah, if you say this, let's do it. And the reality is that now all traffic goes through you. And obviously, the decision now is for you what to do with this information. So you can sniff network traffic, you can passively collect all the sensitive plain text information. Because again, initially it's Modbus. No one thought that this information could ever be intercepted. Another thing, you can also not only intercept, you can also tamper this information, exchange between parties. For example, you can, I don't know, change the registers in PLCs. You can not only read, but also write, and you can change the parameters, send there. And for example, this gives you very interesting opportunity because the system is very, very fine-tuned and all processes there are synchronized up to a second. So if you, I don't know, change any parameters like, I don't know, timestamp or, I don't know, parameters of, I don't know, pressure or voltage or whatever, wherever you can, it means the system immediately sees the deviation and does emergency shutdown. And we tried that and it actually works. So, but what I want to tell you about is actually how we use this technique to intercept and modify queries to central NTP server. So NTP server is absolutely crucial on this ship because it's a source of precise timestamp, and it's just taken and it's just distributed through all those processors or different routers, PLCs, wherever you can imagine. And as I said, it's very important that the timestamp is correct. So obviously, NTP is a complex protocol, and in short, there's something called Stratum. Right? Stratum 0, it's the ultimate time source. It's taken from satellite. It just goes to Stratum 1, which is like a main source of a precise time on the ship, and then it just is distributed across different networks. So let's imagine that we can connect to a router, let's say at the level 2, and we can inject fake timestamps. So if it's completely random timestamp, right? So you think, okay, can we screw the system? Well, apparently we can't, because all those routers and devices, they very carefully analyze the new source of time information. And if this source of time information is very different, those devices are blacklisted. So we thought, okay, so is there a way we can work it out? Because it will, once it's blacklisted, you can't do anything. So we thought, okay, let's take the current timestamp and we can create a deviation which is very tiny, like 1 second or 3 seconds or something like this, something which is in the window of acceptance of devices. And if we say, okay, now it's not, let's say not 6 o'clock, but 6:00:04. So those devices now think, yeah, okay, maybe I'm wrong, actually. Maybe that this is the right timestamp. And they change their timestamp. And then we after some time, we change once again. We do another drift to another 3 seconds and another 3 seconds. And by this method, we managed to quite significantly change the time at different devices. Once again, we managed to do that. Part of the network has a wrong timestamp, and the system automatically does emergency shutdown. So that was a good example for us and also for the team who developed all this system. And they asked us, okay, so what we can do to improve the security of ICS. So I think that it's very important really to change the mindset, because I don't think it's applicable really to ICS only. It's just to IT, as we know, because security is a process. It's one-off event, right? You can only control it once you think about it as an integral part of whatever is happening in your organization. It's a system property. It's not a feature. It's a continual process. It's never a product. So I should probably mention here an interesting example from a completely different industry, from actually car manufacturing, something called the Toyota Way. It's a set of guidelines published, I think, in 2001 by Toyota. And it's a set of guidelines saying, for large organizations especially, saying how you should do your business in a sustainable way. And there are a couple of principles I should mention here. So first is if you know about some problem, it could be security or technical problem, it should be said loud, and it should be fixed as soon as possible. It should never carry on this problem for next couple of months or years. So once there is a problem, it should be addressed right away. So second principle is that everyone in an organization has right to say that there is a problem. It doesn't matter where you are in a hierarchy. If you see something is not right, you should say it, and you have to be heard. And again, the next steps and actions should be taken. And probably the most important principle is, I think it's well known, called continuous improvement, right? Because we all are people, and we humans, and we are making mistakes. And whether we like it or not, we will be making mistakes in the future. But we still want to have a profitable business. So we have to live with it and find a way how we can learn on mistake constantly, continuously, and improve our processes, improve whatever is happening in our organization. So we learn on mistakes, we implement new security features, we conduct another assessment, we review mistakes, and the circle goes again. So that is very, very important. And I want to stress this again. This is not only about ICS, it's about all approach to IT security in general. Another interesting approach I can also recommend, it's just, also well known, it's layered security or defense in depth. So we can visualize it like layers of Swiss cheese. And if an attacker goes to those layers, they could penetrate layer 1 and layer 2, but because those holes are different places, because there is no protection which is ideal, then it will be stopped sooner or later. It will be not maybe stopped by layer 1, but will be stopped at layer 2 or layer 3 or layer 4. This is very, very important because, in security world, many things. Also, you can use analogy from cryptography, right? In cryptography, they say that there is no unbreakable ciphers, right? Whatever matters is really the time you spend on decryption, right? Is it like 10 minutes, an hour, or 10,000 years? So the same thing is also applicable here. If we can successfully demonstrate to attacker that there are some thoughts behind the security, that we can significantly slow them down, we can give them a message. We are looking at this, right? It's under control. So this gives you a chance, first of all, to detect that something wrong is happening, and gives you precious time also to react. That's also a very, very good approach. Another is, I would probably recommend network segmentation. So either physical, that could be, I admit, might not always be easy to implement, especially in already existing environment, but at least virtual, where you can clearly separate fragments of your network to VLANs with very, very thorough traffic control. Therefore, if at least you have a problem in one of segments, there is much less probability that the problem will be expanded to the whole organization. So a bit of a recap, how to make ICS and SCADA more secure. So I would say you have to, first of all, map your network, identify your assets, and understand what do you have. Do you know really what you have? What kind of systems are really crucial? What kind of systems are your crown jewels? What potentially could be attacked by hackers? Can you think about that? Can you step into the hacker's shoes for a while and maybe play a game and think what potentially would be a subject for future attacks. So once you understand and identify those, you can think about reducing the attack surface. Maybe it would be about, I don't know, removing unnecessary services, maybe filtering some IP addresses or ports, or introducing additional security measures. Patching and updating, it's also important, but we know that, especially in ICS world, it's never easy. But I think it's also very important to have, again, more generic approach. So never assume security, right? Never think that you've bought a new firewall and lights are blinking, you connected it, and it works because it says on the tin. No, it's not right. You have always have it tested. You have your team, you have your people, or you can invite someone external, like, I don't know, our organization or any company that is specialized in IT security. They can come and they can get a bit of exercise. They can see how your system really looks from the attacker's perspective. What could happen if attacker is outside of the organization? What if they accidentally already are there? What if someone had a Trojan horse installed on their laptop? What if attacker is already within your perimeter? So we can play those things and we can see how far you can go. That's very, very important, to exercise and exercise and exercise, especially these days when you really see that pretty much every day you see a news about some security breach or security issue at first page of all newspapers. So main takeaways, just to do a quick recap of what I said. I think it's very important to have a holistic approach to security, because this is only key to success. Not only think about little fragments of this and that. People are making mistakes, but people can fix mistakes. So it's very, very important that IT and OT start talking to each other. And quite often, believe me, they are not. So they understand that. I appreciate that these are two different realms, but let them talk to each other, let them share their thoughts about security, let them analyze together, sit and think how they can make the security better in the organization. Definitely, I'm absolutely convinced that no technology would ever help if there was no right policies in place. And again, people not understanding those policies, and they don't see the way how they could be really, really used. No perfect air gap, so we know about this. It probably will never be, but again, layered security might help, and the more layers we have and the more control points we have within those layers, the better, because the early detection we have, the more chances, the more time we can buy, the more options we have to fix the problem. Once again, I will repeat that we have introduced, unfortunately, many well-known attack vectors to ICS, like web and mobile, ICS remote clients like cross-site scripting, SQL injection, etc. So this means even more that those modern, especially modern systems, they should be tested properly, because now we have management interfaces, we have all those management interfaces available over the web, or either from intranet or internet. So if you open Shodan and run a couple of queries, you will see what I mean. So yeah, this must be tested, and it must be tested probably by two main parties, by manufacturers of the equipment, so by vendors of the equipment, and also by organizations like, I don't know, critical national infrastructure that are using this. So important is that we can provide right services to ensure that devices are ready to go to the market, and they are prepared and they are well tested before they can be offered, and before the manufacturer says, yeah, we have a super secure, industrial switch or industrial firewall. And also, once we have connected all together, all those pieces together, it's also important to do the testing, security assessment of the whole system, because there are many little things, many single points of failure that could be introduced at different places where you couldn't even imagine. So the overall thing is much more than a connection of parts. So that's why testing of components is one thing, but testing of the systems or systems of systems, it's very, very important. And last but not least, probably once again I should mention defense in depth. So it's really good, and it's it just works. Maybe it's not the ultimate solution, but it's something that could slow down the attacker, gives you time to think, regroup, and stay safe. Thank you very much for attention, your time, and do you have any questions?
Thank you so much, Aleksander, for your presentation and the very strong message of continual security and resilience. I do have some questions that the attendees have sent, and attendees, if you would like to ask some questions, if you're on Maximise for the presentation, if you just come out of that, you'll see that there will be a question box that you can ask Aleksander additional questions. Let me just ask some of the questions that have come through while you've been speaking. So first of all, is there a realistic way for modern organisations to prevent supply chain attacks like SolarWinds from happening?
That's a tricky question, to be honest, because you can control. Well, you in ideal world you can control supply chain, right? And also I can make an analogy to car manufacturing, where there is a term called traceability. So traceability is literally when they have bombs, a bill of material of a car, for example, right? They can expand it to every little screw and every little thing, and they know who is the supplier, when it was manufactured, what kind of metal or whatever or alloy was used there, what kind of badge or lot or whatever. So it's all is there. So if they have a problem with anything, I don't know, the battery, they can immediately do one click and they know where exactly the battery was taken, who was the manufacturer, what kind of materials, everything. So maybe the similar approach could be used. And again, this is, by the way, where probably blockchain might help, because if we have traceability based on blockchain, this will probably something which will be much difficult to tamper, and it has to give you continuity of the process and continuity of traceability of every component. So if you know that you have a motherboard, you have a device, every little thing there, you know from where, and you can also get where it was assembled, where the device was assembled, what components were used, from where they were taken, etc., etc., etc. It still would not probably prevent from, I don't know, where the device is intercepted in transit, but because obviously if it's state-sponsored attack, probably you're getting into a different realm. But at least if we can imagine some unified system for controlling the supply chain, and maybe again, this I'm just speculating based on this modern blockchain technology. Maybe this would help.
Thank you. And secondly, what is better, to invest in developing or growing your own cybersecurity specialists within your organisation, or to use third parties for conducting assessments?
Okay, I think definitely both. To be honest, both, and I can give you a reason why. Because if you so you need to have, and I can just tell you this from the perspective of an organization that is kind of providing cybersecurity services. Because our ideal client, and actually ideal happy client, is the educated client, right? We don't. And because we want to come and we want to do like fancy stuff, we want to search for serious vulnerabilities, for serious problems, help them with something which is non-orthodox, which requires investment of time and just stimulate our brain cells. And on the other side, the client or the organization should be able to maintain at least something we can call a security baseline. So they need to understand our reports. They need to know, to have enough personnel and quality personnel who can keep an eye on what is happening, use the data from SOC, interpret correctly the data from SOC. So they reach a level where the basic things they can do themselves. So they can do basic scans, they can do basic analytics, they can also fix things by themselves. And at the same time, we can come, I don't know, quarterly or annually, and we can do a proper assessment, again, from the attacker's perspective. Because we are playing with those things for many years. We are improving our level of knowledge, because we have no choice. We have to stay on the top of the wave to be competitive, and also to be competitive, first of all, with attackers. That's most important, because their skill set, they're improving on hourly basis, not on daily. And we have to learn all those tricks of trade and be able to experiment with them, be able to introduce them, and also use with testing. So I would definitely say both. And again, both. I mean, organization can learn from us because there is really not something we want to hide. All these technical details are in our reports, so we can clearly demonstrating how we do exploitation. For example, I think it's also very important in general when you provide the report, you provide all details how the issue can be repeated, how the client can repeat every step. Sometimes it looks like almost like a comics, right? Go here, enter this data, press this button. Now enter another value and another value, and here you go. Here now we can read your data. Yeah. So this is very important because if they cannot repeat, they cannot understand. So it's absolutely pointless if we give them 200 pages report and say, yeah, you're full of bugs, right? It doesn't work. Much more important if it's much smaller but focused and with something that they can understand, repeat, fix, and learn on mistakes.
So in a way, it's, I guess, having a trusted team, but then validating where they believe they are. And I suppose by bringing in external people, it's almost increasing diversity of thought. So you've got a bit of anti-groupthink as well by doing both. So yeah, I love that answer.
I can give you one more example if you want. We were once asked to conduct assessment for a large car manufacturer in Germany, and we were really surprised because they have like a couple of hundreds of people doing security themselves. We just said, yeah, okay, so obviously we will come and test it, but why? And they ask, because we have people who are biased. Right? We want, that was a management point of view, we just want to double check if whatever they do right. Because we know that you have much wider experience. Your eyes are much wider open because you deal with different systems every week. So why not to come and just look if what we are doing right?
Yeah, you see what you expect to see.
For me.
Yeah. Okay, so then the question is, what can the vendors of industrial equipment do to make their devices more secure and robust? I think so. Obviously, again, strong cooperation. Probably, I should probably repeat what I said answering the previous question, because obviously building their own team, building their own testing capability. So security should never be built on. Security should be a process of, development process, either it's software or hardware development. It's integral part. It should be from the blueprints till it's given to the customer. Everywhere. So it should be tested, retested. And again, it's very good if you can invite a third party just to come and double check if whatever you're doing right. So there are industry standards, and you can obviously, you're trying to fit whatever you do to those standards. There are certification labs, so you can provide your device to certification labs, but even before, much earlier, it's purely from my experience and experience of our customers, it's cheaper and better to invest in security at early stage, because if finding something later, it costs more and more difficult, and obviously the consequences, last thing anyone wants is to be on the front page of the newspaper. So it's much better to do it in small, because you'll pay anyway, right? So it's no questions about that. So question is if you pay this or you pay this, and you pay it gradually through all the process, and you can scatter it across your budget, or finally you have to deal with fines and problems and PR, and you don't know what to do. So think in advance, trying to predict the future. Yeah, kind of the fail to plan to fail model. Yeah. Right, I think that's all the questions that we've been asked. So thank you so much, Aleksander. We really appreciate your expertise and time. And for those people watching, don't forget that the hashtag is CRESTCon, so please feel free to share some of this fantastic information that you're receiving today. And we are going to go to a tea break and come back at 11:20. So thank you so much for attending. Thank you, Aleksander, and see you in another.
Thank you, everyone.